Now let's solve the integral with trigonometric substitution. Now I wrote different integral with the format of their trigonometric substitution. So the one we are doing is this one. So let's solve the question. Given integral of the s divided by 9 minus 4s squared. Now this is the question. If you look at this question, it can be in the format of this is the s divided by 9 is 3 square. 9 is 3 square minus 4 is 2 square, then s square. So meaning 4 can be 2 square, s square is still the s square, then 9 can be 3 square. So any integral of this form, so it's the one I wrote as integral of the s divided by a square minus b square s square. Now if you compare these two, you will see that a equals to 3 if you compare, because 3 square a square, so a is 3, then 2 square b is equals to 2. So that means a is 3, b is 2. Take note. Now what do I say the format will represent? So any format of this form, we will say let bs is equals to a sine theta. This will be the trigonometric substitution. So let's proceed. Now we have already changed this to this format, in which we can easily see that a is 3 and b is 2. Now using the substitution, we know that bs is equals to a sine theta. Now substitute, so this will be 3 and b is 2, so that will be 2s is equals to 3, because a is 3 sine theta. That means s is equals to 3 over 2 sine theta. So this will be my trigonometric substitution now. So that's what I will use for my substitution. So now back to the question. Integral of the s divided by 9 minus 4s squared. So I'll first say let s is equals to 3 over 2 sine theta. You have seen how I got this. So that will be my trig substitution. So if I square both sides, then s square will be equal to 3 over 2 sine theta square. So if you square this, we will have s square is equal to 9 over 4 sine square theta. So that is 3 over 2. 3 square will be 9. Then 2 square will be 4. Then sine theta will be sine square theta if you square both sides. So sine square theta. So again, the s the theta. The s the theta means we should differentiate this one. If you differentiate s is 3 over 2 sine theta, Then the s the theta is 3 over 2. So if you differentiate sine theta, you will get cos theta. So we learn this in differentiation. You can use power restraint, you can use first principle. So but you should note it's an identity here. If you differentiate sine theta, you get cos theta. Then if I cross multiply, the s will be equals to 3 over 2 cos theta d theta. As in, because we cross multiply this, the theta will just go there. So that is the x. So let us now go back. That means our question, integral of the s over 9 minus 4s squared will becomes, what is the s? You have known that the s is this. That will be 3 over 2 cos theta d theta divided by 9 integral divided by 9 minus 4s squared. So that will be 4. Now instead of writing s squared, what is s squared? We see that s squared from here, s squared is 9 over 4 sine square theta. So that means this will be 9 over 4 sine square theta. Now as we can see from here, 4 will cancel out 4. So this integral becomes integral of 3 over 2 cos theta d theta divided by 9 minus 9 sine square theta. Now this 3 over 2, we can take it out as constant. It's integral of cos theta d theta. So you write this at the back of the integral. Then divided by, now what is common here? 9 is common. So I'll have 9 bracket 1 minus sine square theta. So that is, if 9 is common, it's remaining 1 minus sine square theta, meaning you are dividing everything by 9. So far is common. Now this 9 can also come outside to becomes 1 over 9 integral of cos theta divided by 1 minus sine square theta d theta. Because this 9, I can take it outside again to be 1 over 9 outside the integral. Now 3 here 1, 3 here 3. So 3 times 2 is 6. So this will be 1 over 6 integral of cos theta divided by 1 minus sine square theta d theta. Now from here we will use the trigonometric identity. We will use trigonometric identity. So from sine square theta plus cos square theta is equals to 1. So this is the trig identity we want to use. Then cos square theta will be equals to 1 minus sine square theta. So that means this 1 minus sine square theta will become cos square theta. So the integral becomes 1 over 6 integral of cos theta divided by cos square theta d theta. Because we have changed 1 minus sine square theta to cos square theta now. So this will becomes 1 over 6 integral of cos square theta, as in this one will cancel out. That will be 1 over cos theta d theta, because if you reduce this it will remain just cos theta there, so that will cancel out. So we'll now have cos 1 over cos theta d theta. Don't forget cos theta will cancel out, it will remain 1 over cos theta. Now in other trigonometric identity, we know that sec theta is equals to 1 over cos theta. That is using social cow. Now this is cosec, that is inverse of sine. If you place it with SOHCAHTOA, so it means cosec is inverse of sine, sec is inverse of cos, cot is inverse of tan. So that means sec theta is 1 over cos theta. So we are using that identity. So that means this will becomes 1 over 6 integral of sec theta d theta. So we have simplified the integral to this form. Now what is now integral of sec theta? Now let me show that part. You can know it and write it straight, you are free, but let me show how we can integrate sec theta d theta. Now if I want to integrate sec theta, this is the same thing as if I say sec theta brackets sec theta plus tan theta divided by sec theta plus tan theta d theta. So look at this expression. This is the same thing as this. How? Because this can still cancel out, it will go back to sec theta. So that means I can say let y, or let me use t, let t be equals to sec theta, let t equals sec theta plus tan theta. So let t equals this, then dt will be equals to, if you differentiate sec theta, you will get sec theta tan theta, then plus tan theta. If you differentiate tan theta, you get sec square theta. Take note, if you differentiate sec theta, you get sec theta tan theta. If you differentiate tan theta, you get sec square theta. Now dt, so this one will be d theta. So now what is common here? You can see sec theta is common here. So that means dt will becomes sec theta brackets, then it will remain tan theta plus sec square theta. Sin theta plus, sec theta is common. So if sec theta is outside, this one will remain just 1, because 1 is common, sec theta d theta. So if you look at this expression here, see this expression here. Go back to this integral here. Now what is sec theta bracket sec theta tan theta? We have seen it that is dt now. And what is sec theta tan theta? We have seen it that is t. So that means this becomes integral of dt divided by t. So that's what we have now. So integral of dt divided by t. So that means integral of 1 over t is ln t plus c. So if you have integral of 1 over x ds, it will give you ln s plus c. So because it's t, so it will be ln t plus c. Now what is our t initially? So that means the integral of the t over t is now ln, initially I said let t to be sec theta tan theta. So this will be ln sec theta plus tan theta plus c. That means integral of sec theta d theta is ln sec theta plus tan theta. So you can know that the integration. So because I'm using it here, so I just show you how I will get it. So that means if I continue here, so this is 1 over 6 integral of sec, because 1 over cos theta is sec theta. So and I've seen it now that 1 over 6, so I'll have 1 over 6 ln sec theta plus tan theta, so plus c. Why? Because I have to integrate this now to get this. So that's how we get that result. So now how can we now go from here? That means we need sec theta and we also need tan theta. So let me clear this so I can show that part. Because using trigonometry, if you watch the first video, I did a video on this in which I use normal substitution and it gives us a fast approach. So you can include this one also. Search for the video of the first one. So now from here, we have seen before, we know that x is equals to 3 over 2 sine theta from beginning. This is our substitution. So from here, do you know if I cross multiply, I'll have 2s is equals to 3 sine theta as in we cross multiply. What is sine theta? Yeah, sine theta is equals to 2s divided by 3. Now from here, you will transform it to a right angle triangle. So look at this. Sine theta is what? Opposite over hypotenuse. Now where is opposite? Here will be opposite. That will be 3 over hypotenuse, which is 2x. So we need to find adjacent. So now to find adjacent, you use Pythagoras Theorem. That is hypotenuse square equals to opposite square plus adjacent square. So that means this will become hypotenuse square. What is now hypotenuse? Our hypotenuse is 2s. So this will be 2s square equals opposite. That will be 3 square plus adjacent. Let's call our adjacent m. That will be plus m square. Now, if you collect the like terms, I've made mistake here. Excuse me. This opposite is not 2s. Let's correct that. So call the adjacent m. Then you can see opposite is up. That is 2s. Hypotenuse is down. That is 3. That means I should have opposites. That is 2s over hypotenuse 3. So it's correct now. I can now use my Pythagoras theorem. So that is hypotenuse square equals opposite square plus adjacent square. So what is hypotenuse? That is 3 square is equals to opposite square. That will be 2s square plus adjacent, that is m square. So what is m square now? Collect like terms. So m square, that will be 9 minus, this is 4s square. So m is equals to square root of 9 minus 4s square. So that means we have known this place. That is the adjacent. So that means the adjacent here is square root of 9 minus 4s square. Now, as we know that place, we can now find sec theta and tan theta. Now, what is sec theta? Sec theta. Excuse me. So if you use show cow, so this is cosec, this is sec, and this is cot. This is sec. So now sec theta is hypotenuse hypotenuse over adjacent HA. So where is hypotenuse? So here it will be 3 over adjacent. What is adjacent? Is the one we found now. So 3 over square root of 9 minus 4s square. Now what of tan theta? So from SOHCAHTOA, tan theta is opposite over adjacent. So this is opposite. So that means we have 2x over adjacent. That is square root of 9 minus 4s square. So we have known our sec theta and we have also known tan theta. So that means from here now, we can proceed with the workings from here. So from here, I can say sec theta is equals to 3 over square root of 9 minus 4s square. Likewise, tan theta is equals to 2s over square root of 9 minus 4s square. So if I put it in this expression, so I'll have 1 over 6 ln. So now the ln is, this is ln, but small letter l. So now sec theta, that is 3 divided by square root of 9 minus 4s square, plus tan theta, that is 2s divided by square root of 9 minus 4s square, then plus c. So if you stop here, you have not simplified further, so we can still simplify further. So this will be 1 over 6 ln LCM is square root of 9 minus 4s square. So this in this is 1, then 1 times 3 is 3, plus this in this is 1, then times 2s, that is 2s. So plus c. We found the LCM here. Now we need to simplify further again. This will be ln. I can have a common root here, but if I have a common root, this will be 3 plus 2x square divided by 9 minus 4s square. Why? Because this root, we cancel out this 2, it will go back to this form. So that means we just have common roots there because of our simplification. So now if you look at this one here, it can be difference of 2 square. that is 3 square minus 2s square. This is difference of 2 square, so I can show that in the next step. So that means this is equals to 1 over 6 ln square root of 3 plus 2s square divided by 3 square minus 2s square plus c. So this is the same thing as 1 over 6 ln square root of 3 plus 2s square divided by, now this is difference of 2 square, so which should becomes 3 plus 2s and again 3 minus 2s plus c. So now 3 plus 2s will cancel out. It will remain 1 over 6 ln 3 plus 2s divided by 3 minus 2s plus c. But there we have a square root. Remember, we still have square root. This is the only one that cancel out. So from here we can still simplify further from here. So I can have 1 over 6 ln 3 plus 2s divided by 3 minus 2s raised to power half plus c. Why power half? That square root can become power half. Now in logarithm, if I have ln a raised to power b, this is the same thing as b ln a. This b can go to the back. So from this expression, we can have 1 over 6 times 1 over 2. So this power will come down. Ln 3 plus 2s divided by 3 minus 2s plus c. So which is the same thing as 1 over 12 ln 3 plus 2s divided by 3 minus 2s plus c. So that is the answer. So that means integral of ds divided by 9 minus 4s square is equals to 1 over 12 ln 3 plus 2s divided by 3 minus 2s plus c. So we have solved the question using trigonometric substitution. Now if you watch the first video I did on this integral, I did not use trig substitution. That one is still shorter, so you can still go with that one. So I'm just doing this. Now what if you don't want to do all this? In case of objective exam, what do you think you can do? So if you have objective exam, so let me give you an expression. So let's say we have objective exam. We can say integral of the s divided by a square minus b square s square. Generally, this can be 1 over b square integral of the s divided by a over b square minus s square. So which is the same thing as 1 over b square times 1 over 2 brackets a over b ln a over b plus x divided by a over b minus x plus c. So which is 1 over 2ab ln a plus bs divided by a minus bs plus c. So from here you can also get the result. This is the approach I used in the first one, but here I change it to arctange from here. But instead of the arctange, we can go further this way. That means you should now note now, in case of objective exam, the integral of the s divided by a square minus b square s square is equal to 1 over 2ab ln a plus bs divided by a minus bs plus c. So if we relate this with our question, this will be integral of the s over 9 minus 4s square. Remember, this is the same thing as integral of the s divided by 3 square minus 2 square s square. So in which a is 3 and b is 2. So if you substitute in our formula, so you will get 1 over 2ab. 2ab means 2 times a is 3, 2 times 3 times b is 2 ln. Now a plus bs, a is 3, that will be 3 plus b is 2s divided by 3 minus 2x, then plus c. So which is equals to 1 over 12 ln 3 plus 2s divided by 3 minus 2s plus c. So which is our previous result. So that means you can use this formula in case of objective exam. So that is general formula. So now, what's the first video? You have seen the approach in terms of arctange. I gave the answer in terms of arctange 2s over 3, as in 1 over 6 is here. So, and instead of changing it to arctange from here, so I use another simplification. So I got this. So take notes. Thank you.